everybody, welcome to Kandela IAS. I am Shobha GC and today we'll do a session on environment. The topic for today will be carbon biogeochemical cycle. So let us start and first see what is a biogeochemical cycle. So when you look around yourself in the environment, there are biotic factors and abiotic components. Biotic components comprises of plants, animals, microorganisms, etc. Those are basically the living components of Earth. Abiotic components include hydrosphere, atmosphere, lithosphere, sunlight, temperature, etc., which are largely the non-living components. So, life for it to exist on Earth, we need abiotic components because from abiotic components, we derive energy. Energy is nothing but flow of chemicals from abiotic components to biotic components. So, chemicals flow from abiotic components to biotic components and back to abiotic components, thus forming a cycle of circulation. This cycle of circulation provides us with energy and essential nutrients. So when these chemicals circulate in a cycle, we call this as the biogeochemical cycle. So there are major biogeochemical cycles comprising of hydrogen cycle, carbon cycle, nitrogen cycle, sulfur cycle, phosphorus cycle, etc. And today we will try and see the importance of carbon as a chemical in biogeochemical cycle. So let us see what are the basic features of carbon. So carbon as a cycle, when you look at it, it is a gaseous cycle. Gaseous cycle meaning carbon is absorbed from atmosphere directly by the plants and converted into glucose, that is energy. So it is absorbed from the atmosphere, hence we call it as a gaseous cycle. All gaseous cycles are instant cycles because they are readily absorbed and readily converted into energy. Gaseous cycle of carbon is an efficient cycle because when carbon is absorbed by plants, it is converted into energy, making it efficient. And most of the carbon that is absorbed by Most of the carbon that is absorbed by the plants is efficiently converted into energy, making it an efficient cycle. Carbon is not a major constituent in our atmosphere. It only comprises of 0.03%. However, it is not a small component because it is one of the essential gases in our atmosphere. So what is an essential gas? So during daytime, when you look at the atmosphere or the surroundings around you, there is solar insolation received. This solar insolation that we receive is converted into terrestrial long wave radiations to give us heat and warmth. So after sunset, heat and warmth disappears and our earth doesn't become cold. Why? Because there is presence of greenhouse gases. Greenhouse gases are efficient gases which absorb these daytime terrestrial long wave radiations and trap heat. This heat helps us keeping earth warm during night. So this warmth helps life survive on earth. Hence carbon being a greenhouse gas becomes an essential gas without which survival on earth becomes impossible. So carbon is not a pollutant. In fact, it is an essential gas which has made life possible on earth. So let us now look at the reserves of carbon that is present on earth. Largest stock of carbon is present in the rocks of earth, that is in the lithosphere. So let us now see carbon reserves on earth. Carbon reserves means where is carbon stored on earth and in what proportion it is stored. So carbon is stored largely in the lithosphere, that is the rocks of earth. That is the largest reserve on Earth. Other than that, carbon is stored in the oceans, atmosphere, soil, plant biomass, etc. When you look at the stock of carbon in oceans, it comprises of almost 37,000 gigatons of carbon. Other than that, if you see, soil has around 2,300 gigatons of carbon and atmosphere has around 800 gigatons of carbon. So when you compare oceans and the atmosphere, you can see that oceans have almost 50 times more carbon when compared to atmosphere. So you can say that oceans have large stock of carbon. What is the role of ocean in your carbon storage? So when you look at your water, that is ocean water, your sea water, river water, etc., it is in continuous contact with your atmosphere, and there is transfer of carbon from atmosphere directly into water and from water back to atmosphere. So there is direct exchange of gases between atmosphere and the oceans. So this forms a important part in the exchange of carbon gas from atmosphere to oceans. Oceans help in maintaining the equilibrium of carbon. What do we mean by equilibrium of maintenance of carbon? So when there is excess carbon in atmosphere, oceans absorb that excess atmosphere carbon into itself and store it in the water bodies. When there is less carbon in the atmosphere, when atmosphere becomes deficient of carbon, carbon is released from the oceans back to atmosphere. So oceans are a very important part which help in maintaining a standard rate of carbon in the atmosphere. When it is excess, it is absorbed, and when it is less, it is released back into atmosphere. So oceans are largely buffers which store carbon and help in regulating the atmospheric levels of carbon. So oceans have high amount of carbon, means there is more carbon stored in the atmosphere which is getting transferred to the oceans, increasing the level of carbon in the oceans. So now let us look at the carbon cycle. So you can see the picture here. Carbon dioxide is present in the atmosphere. So carbon is present in the atmosphere in the form of carbon dioxide, methane, etc., where carbon dioxide is the most abundant gas found in the atmosphere. So you have carbon dioxide in atmosphere which is absorbed by the plants. Why do plants absorb carbon dioxide? Because they have to do photosynthesis. So if you are aware of photosynthesis, it is a process where carbon dioxide in presence of sunlight and chlorophyll with water combines to form glucose, that is C6H12O6, and it is stored in the plants because plants have glucose. So this is the process of photosynthesis where plants absorb carbon dioxide and convert it into glucose and store it in the plants. Now these plants are consumed by primary consumers like sheep, goat, cow, deer, etc., which eat these plants, and your carbon from the plants in the form of C6H12O6 gets transferred to animals. These animals now further in the food chain are consumed by secondary consumers, tertiary consumers like cheetah, leopard, tiger, etc., and the flow of glucose continues in the food chain. Now, we have seen that carbon is absorbed by the plants and enters into the animal bodies. So, this is absorption of carbon from abiotic components into biotic components. That means carbon has entered the biotic components. Now, next, what happens is this carbon is released back to the atmosphere. So now we saw the absorption part, we have to see the release part. So how is carbon released from animals and plants back to atmosphere? Okay, so it is released when there is death of plants, animals, etc. It is released by volcanic eruptions, weathering of rocks, etc. And it is also released by the burning and decomposition of plants. So let us just look into this in a little more detailed manner. So when we see this carbon cycle, I have already told you, and it is visible in the diagram, that producers, that is the plant community, are the first absorbers of carbon, and then it is transferred to primary consumers, secondary consumer and tertiary consumer. So this is the absorption part. Now, when we see the release part, you can see that carbon is released back into the atmosphere by natural methods and anthropogenic activities, that is human-based activities. So first, let us look at the natural cycle of carbon, where carbon is released back into the atmosphere by natural processes. So in natural processes, if you see, we are continuously respiring. So when you do respiration, what are we exactly doing? We are absorbing oxygen and giving out carbon dioxide because we have eaten plants and there is C6H12O6 in our body and carbon has to be released. So when you burn energy, carbon is released. So carbon has to be released and it is released through respiration. Oxygen is absorbed and carbon is released from our bodies. So when we do this respiration, carbon enters the atmosphere. When you look at plants, plants perform photosynthesis during daytime. That means they are continuously absorbing carbon dioxide and releasing oxygen. But what do plants do at night? At night, plants also do respiration. That means plant is absorbing oxygen and releasing carbon dioxide. So, does it mean that does the plant release all the carbon dioxide that it has absorbed during the day? Definitely not. So now let us see plants. So what do plants do during daytime? You are aware that they do photosynthesis. They absorb carbon dioxide and release oxygen. But what do plants do at night? Do they do photosynthesis? Absolutely not, because there is no sunlight. So they will also do respiration, meaning plants will absorb oxygen and release carbon dioxide. Whenever a plant stops photosynthesis, it starts respiration. Means it will absorb oxygen and release carbon dioxide back into the atmosphere. Does this mean that whatever carbon that was absorbed during the day by the plant is released back to the atmosphere at night? No, that is not the reality, because plants absorb lots of carbon during day and respiration is a slower process and less carbon is released during night. Plants store twice the amount of carbon within themselves that is released during night. So there is more carbon stored and less carbon released during night. So the process of respiration by both plants and animals releases carbon into atmosphere. So this is one of the natural processes. The next natural process is upon the death of plants and animals. Upon the death of plants and animals, carbon is released back to the atmosphere during the process of decomposition or combustion, etc. So death releases stored carbon in plants and animals back to atmosphere. When you look at the roots of the plants, it is very, very important to loosen the soil for a healthy growth of a plant. So why do you need to loosen the soil for a healthy growth of a plant? Because air has to enter the soil. You need good air circulation in the soil for a healthy plant growth. Why is air important in the soil? Roots do respiration. Roots must respire. Hence, roots absorb oxygen and release carbon dioxide. So, roots, when they respire, they are releasing carbon dioxide back into atmosphere. When you look at the soil, soil is one of the most biodiverse components on earth and has lots of microorganisms. Microorganisms are generally short-lived and they involve in various chemical activities, and they are one of the major components which release carbon dioxide into atmosphere. Other than this, we see in weathering of rocks or soil erosion processes where we witness that carbon is released from lithosphere to atmosphere. Weathering of rocks, breaking down of rocks, soil being removed and exposing the underneath layers of earth will release carbon back into atmosphere. Volcanic eruptions release lots of carbon into atmosphere. So these are the natural processes where carbon is released into atmosphere. So now let us see the next part, that is the anthropogenic activities that release carbon into atmosphere. So humans are involved in various activities. Most of them are causing destruction to the environment. So when we do all these activities for our industrial revolution, mechanization, etc., we are releasing lots of carbon into atmosphere. So which are the dominant processes which human beings are involved, which release lots of carbon? So the first one that you would have seen around you is the burning of fossil fuels. It can be coal burning in thermal plants, or it can be your fossil fuels burning to run your vehicles. So fossil fuels like coal, oil, crude oil, etc. release lots of carbon into atmosphere. With growing population and increasing demand for energy, we see that fossil fuels are one of the largest contributors of carbon into atmosphere. Industrial processes release carbon into atmosphere. Mining, large scale uncontrolled mining, constructional activities where we are digging it deeper into the lithosphere is breaking down rocks and it is releasing carbon into atmosphere. Deforestation causes loosening of soil and soil is eroded very easily, which exposes the underneath layers of lithosphere, and these underneath layers of lithosphere which have carbon stored in them gets released to the atmosphere. These are some of the urban activities that we have seen which releases carbon into atmosphere. But rural activities as well release carbon into atmosphere. Like for example, agriculture. So in agriculture, where do we see release of carbon? Agriculture releases methane. So where do we see CH4, methane gas being released? So when you see agriculture, dominantly world staple food is rice. And rice needs standing water for cultivation. So when we stagnate water and there is standing water, there is anaerobic respiration taking place within water. This anaerobic respiration releases methane. So paddy cultivation is considered to be one of the major activities which releases methane, CH4, meaning carbon is released to atmosphere. And with growing customization of agriculture and monotonous type of agriculture, we dominantly see paddy cultivation all around the globe, and this is releasing lots of carbon. The other activity which is not urban and is releasing carbon is animal husbandry. How does animal husbandry now release carbon? Animal husbandry, when you see, it is done in large scale in the Western countries and all around the globe. So, large scale livestock rearing means you're rearing animals like cow, sheep, etc., mainly for food purpose and for obtaining milk. So, when you feed cow, cow eats grass and in its stomach it breaks it down. It breaks it down with the help of ruminants. But this breaking down of grass in the stomach of herbivorous animals releases methane again. Why? Because there is again anaerobic respiration taking place in the stomach of the herbivorous animals. So these are the dominant causes of release of carbon into atmosphere. So when you look at this, we clearly find that human beings are solely responsible for large scale release of carbon into atmosphere when compared to the natural processes. Natural processes always maintain equilibrium and human beings interfere into these natural cycle flow and cause disturbance in the balance of carbon in the atmosphere. So when did we start with this imbalance? So industrial revolution took place in the Western world around 1800 AD. And from then on, we have started harnessing energy and we are releasing a lot of carbon by producing energy to run our machines. The more automation, the more real time we become, the more carbon we are releasing as it is more energy demanding. So more energy, more carbon is being released. This increase of carbon in atmosphere, does it have any impact? It definitely has a larger impact than we can imagine. So when you see this carbon, I in the beginning told you that it is a greenhouse gas. Means the work of carbon is majorly to store the heat of terrestrial radiations that are released during day. And these radiations that are released during day is not absorbed 100% by carbon. Instead, it only absorbs a certain part of it and allows rest of the heat to escape from Earth's atmosphere. When the levels of carbon increase in atmosphere, more heat is trapped, meaning it does not allow terrestrial radiations to escape directly. More heat, more increased temperature of atmosphere means there is global warming. This global warming gradually leads to climate change, and we see around us the impacts of climate change, which are mostly in the form of disasters. Climate change is affecting each and every part of the globe, and there is no advantage obtained from climate change. Carbon is considered to be one of the main components that is causing climate change. What happens now when there is excess carbon in the atmosphere? I told you oceans act as buffers. When oceans act as buffers, it means that when there is excess carbon in the atmosphere, it automatically gets stored in the oceans. It is transferred directly into oceans. So when levels of carbon dioxide increase in the oceans, it causes ocean acidification. What is ocean acidification? It is transfer of carbon from atmosphere to the oceans and carbon getting converted to carbonic acid in the oceans. Carbonic acid in the ocean water causes harm to the biodiversity, especially the shelled organisms. So when we look around, shelled organisms comprise of calcium carbonate and carbonic acid is capable of dissolving calcium carbonate. So calcium carbonate, when it dissolves, it threatens the life of shelled organisms. It also threatens corals which fail to build coral reefs, because coral reefs, the major component is calcium carbonate, and carbonic acid dissolves calcium carbonate, destroying our coral reefs. So ocean acidification has larger impact on the biodiversity of the oceans. So we have to regulate the levels of ocean acidification. Due to these two factors of climate change and ocean acidification, we can see that there is habitat loss. When there is habitat loss, animals cannot survive. They need favorable environmental conditions to survive. They need their own habitats to survive. So when we are causing a change to their atmosphere, to their environment, to their habitat, animals start getting extinct. That is nothing but biodiversity loss. So you can see that increased levels of carbon because of human based activities is causing climate change, ocean acidification, and threatening the habitat both on the terrestrial surface of earth and the water bodies of earth, causing habitat loss and loss of biodiversity. So, is it now needed to reduce the atmospheric levels of carbon? That is the need of the hour, and we need to reduce the atmospheric levels of carbon. So, how do we now reduce carbon from atmosphere? So, one of the methods is to reduce the amount of emission itself. So, cutting down emission is one of the important steps that has to be undertaken. So, how do we cut down carbon emission? We have to reduce the use of fossil fuels and instead shift to using more renewable sources of energy like solar, wind, etc. So this is one of the methods where we cut down emission of carbon and we help in regulating the levels of carbon. But there is already carbon present in the atmosphere in excessive levels. So it is necessary now to trap this carbon and reduce the levels of carbon from atmosphere that is already present. So this process of trapping that excessive carbon from the atmosphere is known as carbon sequestration. So carbon has to be captured and it has to be stored for long term in certain places. These places where you store carbon is called as a carbon sink. So carbon sequestration and carbon sink are very, very essential to reduce the levels of carbon that is already present in the atmosphere. So in this method, we will be able to reduce the levels of carbon dioxide and help in controlling the climate change impact. If not, then the equilibrium that is disturbed by human activities in the natural carbon cycle will lead to disasters and more worse catastrophes. So today we have seen carbon cycle and I hope it was informative and it was of some help to understand in a better manner. So I hope to see you in further lectures, and if you have any queries, please do get in touch with us on social media. Thank you so much for your valuable time. Have a nice time. Thank you.